Welcome to this Maths Made Easy video on straight lines. To start with, let's discuss the equation of a straight line. So first let's just give the equation of a straight line. And the equation of a straight line is simply given as y minus y1 here, and this is equal to m, which represents the gradient here, times x minus x1. Okay. Now the above is the equation of a straight line through 2 points, and those 2 points here would be x1, y1 and x2, y2. So we write it in full here, x2 and y2. Now, the first point is present clearly in the equation, and the second point is used for the calculation of the gradient m. And the formula we use to calculate the gradient here for m is simply y2 minus y1 divided by x2 minus x1, and you might be familiar with this formula already from your studies in GCSE Maths. Now let's just discuss a quick example here. So for example, if we want to find the equation of the straight line through these 2 points, so let's say this example here, we want to find the equation of a straight line through the 2 points here, 1, 3 and 2, 5. Okay, what would we do first? Well, first here, what we're going to do is simply calculate the gradient. And to do the gradient here, we just use this formula for m. So m is equal to y2 minus y1. So here I'm going to call this my y2. So that's 5 for y2 minus y1, which will be 3 here. So that's 5 minus 3 divided by x2. So in that case, x2 is this 2 here minus x1, which will simply be the 1 here. And if we simplify numerator and denominator here, 5 minus 3 gives us 2 there, and our denominator, 2 minus 1, simply gives us 1. So we get 2 over 1, which simply gives us 2 there. Okay. So in that case, using the equation of a straight line here, in that case, our equation of our straight line here is going to be simply y minus 3, and here, again, it wouldn't matter which of these 2 points that we substitute this into, so y minus 3 is equal to 2 lots of x minus 1 there. Okay, using this coordinate as well as x minus x1 there. Okay, so that gives us the solution to our example and gives us everything we need there for the equation of a straight line. Moving on now to take a look at converting between forms of straight lines. Now there's 3 forms of straight line equations that we need to be familiar with. We have already met y minus y1 is equal to m times x minus x1. Okay, so we're already familiar with this expression. However, there's 2 other straight line equations that we need to be aware of, and they are y equals mx plus c, which you might recognise from GCSE Maths. We also have ax plus by plus c equals 0. Now you need to know how to reach both of these forms using the original expression here of y minus y1 equals m times x minus x1. So let's show how we derive both of these results, and I'll highlight this in a different pen colour just to make this clear. So let's call this equation 1 here. So how do we derive equation 1 starting from this result here? Well, if we write our original result out first, so y minus y1 is equal to m times x minus x1. Okay. So the first thing I'm going to do here is just expand this right hand side. So the left hand side will remain the same, and my right hand side here will be mx minus mx1. Now if we want this in the form y equals mx plus c, all I need to simply do here is add y1 to both sides. So therefore y is equal to mx plus y1 minus mx1 there. Okay, and that result there gives us this form here of y equals mx plus c. So that's how we derive the first equation there. How would we derive the second equation here? Well, again, let's change our pen colour to make this clear. For equation 2 here again, starting from this expression given first, so we write that out again, y minus y1 is equal to m lots of x minus x1. And again, just like we started with equation 1 here, we just expand the right hand side first. So this is y minus y1 is equal to mx minus x1 there. Okay. Now, in this case, remember what we want here is ax plus by plus c equals 0. So in that case then, all I'm going to simply do here is take everything onto this right hand side here. So in that case, we're going to minus y, and we're going to add y1 to both sides. So this will set this left hand side equal to 0. So therefore, what we get here is mx minus the y plus y1 minus mx1, and this is equal to 0 there. Okay, and that's the result we require here for equation 2. It's also important to note here, when we're using equation 2, traditionally what you'll find here is that we will multiply through by a factor to make a, b and c whole numbers. Okay, and that will often be stated in the question. Okay, but that gives us everything we need there for converting between forms of straight lines. Finally, moving on now to take a look at parallel and perpendicular lines. So we say two lines are parallel if they have the same gradient. And we also say two lines are perpendicular if the gradient of the second line is the negative reciprocal of the gradient of the first line. So let's just say we've got two lines here, L1 and L2. Okay. Well, this means they're parallel if the gradient of L1 is equal to the gradient of L2. So for these to be parallel, that means the gradient of L1 is equal to the gradient of L2. So gradient of L1 is equal to the gradient of L2. Okay, so that's our definition there for parallel lines. And for perpendicular here, again using L1 and L2 to represent our two lines here, well, we say they're perpendicular if the gradient of L1, so let's try this out in full here. So they are perpendicular if the gradient of L1 is equal here to the negative reciprocal, so that's minus 1 over the gradient of L2. Okay, so gradient of L2. Okay, so minus 1 divided by the gradient of L2. You could also rearrange this here to prove or to show that the gradient of L1, this also shows here the gradient of L1 times the gradient of L2 here would be equal to minus 1. Okay, but that only holds if the two lines are perpendicular. Okay, but you might find that useful when calculating perpendicular lines and gradients there. Okay, and a quick tip here is that it's easiest to compare gradients if you put the lines in the form of y equals mx plus c. Okay, so if you use y equals mx plus c, it's easiest to see the gradient in this form. Okay, so that gives us everything we need there for parallel and perpendicular lines, and that concludes this Maths Made Easy video on straight lines.